Welcome to Digital Toolbox. In this tutorial we're going to expand our basic attractor curve definition where this curve, these circles react to this curve, and expand this to where we don't have just two circles, a small circle and a large circle, but the radius of the circle is actually defined by its distance from the curve. So here's that dispatch definition. You can go back and view that tutorial to get up to speed here. But we can just go ahead and delete most of these buttons. So now we're left with just our hexagrid, which I'll go ahead and preview again, and then our closest point, and that gives us a whole bunch of points on this curve that we've defined, and the closest point to each one of these individual points on our grid. So we're just going to analyze these with a basic distance formula, and this A will be these points on the CP button, and then the B will be our original points, and then this will give us a whole ton of values, over 1,000 values for just these points that we have here. And then from there we just create some basic CNR curves, and these curves are going to be set on our hex geometry. So on each one of these on the grid, we'll unpreview the grid, and you can see there's a circle on each of those points there. And then the radius of the circle we could set up to a slider, but we want that radius to be defined by this distance. So here you can see it's already giving us that. So the grid is still there, and there's just circles based on the distance that the curve is to each of those points. So we can reduce this down a little bit, and we'll take an F1 function and do x over 4, let's do, and we'll send that through our radius. So, and we can turn off the CP points, unpreview that. So here's a little bit more reasonable output, where the circles are really small if they're close to the line, but a lot greater if they're further away. And just like our original point attractor definition, we can throw in a minimum and ask it for the minimum point between either that function of the distance or the original distance between the points, and it'll take all the really large ones away. So if this got really big, and the further away they are, the larger they get, and it can really interfere with our geometry here. If we just put a minimum on, it'll take the smallest one. So even if we get really far away, it'll take the smaller value, which is the distance between the points.